It's good to be with you. Welcome to Class Outside. Today, we are going to learn some lighting basics in Blender. What is the purpose of light? Without light, there is no vision. Everything we see is reflected light. In Blender, we have a variety of options to add light to a scene. We have light objects, which are lights we add and place throughout the scene. And we have the Emission shader, which can turn any mesh into its own light. And we have the world texture. This texture encompasses the whole scene and describes light coming from all directions. The world texture can be set as a procedurally generated sky texture or set as an image called an environment texture. Let's begin by looking at our light objects. Here we have 4 options that each represent different sources of light and have different effects on the scene. These options are point, sun, spot, and area. Each of these lights share some common traits. They all have a value which represents strength. The strength usually determines the fall off or distance where the light is less impactful. They also have values which determine how blurry or diffuse the resulting shadows are. Shadows blur when light interacts with the surface at many angles. If each ray of light came in a straight line, the shadow would be crisp. When the light beams hit a target at many different angles, the shadow is cast in multiple directions, overlapping other shadows and causing the blur effect that we see. Let's look at the first light object, the point light. We can think of a point light as a sphere that emits light in all directions. As we adjust the strength, we see the distance of the light's influence rise and fall. Here, shadows are modified by the radius or size of the sphere. A smaller sphere has less surface area, and the light leaving the sphere strikes the object at fewer angles, causing a harsher shadow, while a larger surface area leads to more angles connecting with the object and a blurrier shadow. Point lights are useful for lights meant to only affect the nearby area and come from a distinct location or point in space. Some common examples are lamps and rounded light bulbs. Because of the fall off, a point light would not be suited for something like the sun. To notice our sun's fall off, we would have to look at some very far away planet. What if you want light that comes from more than just one spherical point, like a rectangular fixture or what comes from a TV or a cell phone? For this, you can use the area light. An area light is a flat plane that emits light in one direction. It acts like a point light that is being channeled through a solid surface. This adds directionality to the light. The direction of the light can be changed by moving the dot connected to the object. Shadows here are affected by 2 values, size and spread. Spread identifies how the rays of light are emitted from the source. A low spread means the rays should be more similar to direct, straight lines. A wider spread means rays will come from a variety of angles. This makes the light's impact wider and blurrier. A wide spread is why a ceiling light will still affect the wall beside it, and a smaller spread, like a keyhole, may only illuminate what is directly in front of it. A larger size means a larger surface area, and a larger surface area, again, means a blurrier shadow. For area lights, it also means the power is spread thinner across the surface, and the light begins to fall off at a shorter distance. The shape of the light source can be changed. Some common shapes are already provided. If your desired shape is not here, like for instance, the star shape, you should be able to get a similar effect by placing the light behind a mesh with your desired shape. Some real-world examples of an area light could be a backlit display. These lights can even be useful when setting up something like a window. The next light in Blender is the spotlight. This light is similar to an area light. They are both directional. The direction can be manipulated by rotating the object in the 3D viewport. Instead of emitting light evenly across a flat surface, the spotlight emits outward across a curved surface. The angles of the light rays form a cone as they extend from the source. Here, shadows again are blurred by the radius of the light. Like a flashlight, we can think of the source as the light bulb, and the radius as the lens size through which the light passes. This lens is curved and distributes light at different angles to form the coned shape. This can be visualized by moving a cone with a large radius closer to an object. Eventually, a donut shape will appear, showing the emitter's source has passed through the object in the center before the sides of the emitter could. A unique feature of the spotlight is the spot size. This adjusts the area of the directed light, or the size of the cone's base. Another way to think about this is revealing or hiding more of the semi-spherical lens. While more of the semi-sphere is emitting outward in more angles, the radius of the sphere has not changed. The last feature worth pointing out is the bend value. This is useful to blur the edges of the light. Some real-world examples of spotlights would be those on a car, a stage, or how light may peer through a magnifying glass. Speaking of the sun, it has its own light category in Blender. This light has no fall-off. This is similar to the real sun, whose fall-off may not be easily noticed without traveling far away from our planet. The sun's position in the scene does not matter. We can move the sun below a plane and it will still illuminate the top. Instead, the sun's object's direction is what matters. The direction is described by this movable dot. A helpful way to think about this can be to think of the dot as Earth and the sun icon as the sun. So if the Earth is to the right of the sun and we imagine our scene to be on that Earth, the shadows will appear on the correct side of the scene. Even if the sun object appears to be to the right of our mesh, this is because the position, again, does not matter. The direction does. Angle is another setting and describes the angle of the light, not the sun. In the real world, the sun being high in a clear sky should cast very sharp shadows, as the light rays are very straight and uninterrupted. On a cloudy day, or when the sun is lower in the sky, more material and atmospheric gas is in the way of the light, and this affects the angles of the rays. With light striking less direct and with more angles, the shadow becomes blurred. To simulate cloudier days, or more material between the sun and the object, a higher angle is recommended. And for sharp shadows in clearer skies, a lower angle would be recommended. The sun's light is global and affects everything without fall-off. This light can be useful when trying to create outdoor scenes. Outside of Blender's light objects, there are a few more ways to add light. The emission shader is a way to emit light directly from the meshes. By adding a sphere and giving it a material, we can adjust the emission value's strength and see how the scene changes. We can also see that this form of light does have fall-off, and the impact of the light changes based on how far the mesh is from another object. Emission shaders are useful when you want light to come from a non-standard shape. This can be useful when you want light to come from even only part of a surface, or changing parts over time, similar to an animated display. World lighting adds light throughout the scene. This has no fall-off, affects all objects, and should come from every direction. We can start this by going to our Render tab and making sure Transparent is turned to off under the Film section. After that, we want to go to the World Properties tab and click New. Clicking the dot next to Color gives us many options. We look at Sky Texture first, and then we'll look at Environment Texture. If we go into Rendered View, we can see a gradient has taken over the background. This is a procedurally generated sky that lights the whole environment, and we can affect it from the side panel here. We can change the size of the sun, again affecting the blur of our shadows. We can change its elevation and rotation, affecting the direction it comes from. Adjusting fields like air and ozone further alter the effects of the lighting on the scene. This texture is similar to the sunlight object, however it has some additional parameters that contribute to the overall result. Lastly, we have the environment texture. Here we can load a file, usually an HDR or an HDRI file. These images display the contrast and lighting surrounding a scene. We can still affect the strength, however we cannot adjust the source of the light. The light comes unevenly across the sphere around the scene. Therefore, the brightest portion of the HDR image will represent the strongest light in the scene and affect the shadow. Look at that! Together, we have learned a bit about lighting in Blender. Please let me know down in the comments what you thought of this video. Have a great day, and thank you for attending Class Outside.